Amir,
Yes, I'm sorry.
right now. 28 pin devices have 5 analog to digital input channel, and while 40 and 44 devices have 8. Parallel slave port is implemented only on 40 and 44 pin devices. So we cannot interface a parallel slave LCD display with this variants like 28 pin chips. We cannot do that because in 40 and 44 pin only they have implemented that one. Right. So here available features are summarized in table 1.1. Block diagram of PIC16F873A, 876A and 16F74A, F874A and 16877A devices are provided in figure 1.1 and figure 1.2 respectively. The pinouts of these devices families are listed in table 1.2 and 1.3. Additional information may be found in PIC Micro Mid-Range Reference Manual. This is another manual which may be obtained from a local microchip sales representative or downloaded from the microchip website. The reference manual should be considered a complementary document to this data sheet and is highly recommended reading for better understanding of device architecture and operation of the peripheral modules. So if you want to get more detail about the chip, you can even refer this one. So here they have given a table. Right. In this, we have to concentrate only on this last column. It is like operating frequency DC 20 MHz, and then the resets and delays, power on reset, brownout reset, those things are provided here. Flash memory is 8K. Data memory. So here you have a doubt. See, you are saying something. What you are saying is little bit confusing to us. Here you said flash program memory is 8K, but here you said flat program memory is 13K. That almost 14.3K. Which one is true? Now we have a confusion, no? Actually, this is like 8K 14-bit words. Yeah, when you give 8K 14-bit words, you will get 13.5K, 14.5K bytes. This is not byte. This 8K is 18K into 14-bit words. That is what you have to understand. Because all instructions in this microcontroller is 14 bits wide. So if you want to do any valid action using this microcontroller, you require minimum 14 bits to give a instruction right now. That's why only you can store, though there is a 14.5K byte, 14.5 bytes of memory, 14.5K bytes of memory available, you can only do 8K actions because that much of instructions only we can store there. That is what they are trying to say here. Right. Data memory wise, we have 368 byte. EEPROM is 256 byte. Interrupts are 15. Totally we have 5 ports, 3 timers, and comparator, capture compare PWM models 2, multi-channel buffered serial port, MSSP, and USARD, parallel slave port, 8 input channel analog to digital converter, 2 analog comparator, 35 instruction, 40 pin PDIP. We do have other option. We will work with PDIP. PDIP means DIP design.
So ADC will be one only, right, sir?
ADC is one, but we can digitize from 8 different input channels. Physically, there will be only one. Again, here also it is misleading. 10-bit analog to digital module, they told. 8 input channel. Don't think that 8 ADC will be there. One ADC, but 8 different channels, they can get the inputs, right? But they can digitize only one channel input at a time, right? So how can we select which channel to digitize first or second, something like that? For that, they have a register, function register to choose, that we will see in upcoming discussion. So we can make a selection from which channel we are going to digitize at a particular time. But ADC wise, it will have only one ADC will be there physically in a microcontroller. This is block diagram. See here, program bus. I think this is for 3 NO. Let us see 7A. Flash program memory. Program memory bus is how many? 14-bit in size. Program counter is 13-bit in size. So we have 8 levels of stack. Each one is 13 bits. Why it is 13 bits? Because it is 14-bit instruction right now. So to store that 8 dip in a stack at a time, you can have 8 different memory locations. You can push into that, right? You cannot push more than 8. Even if you push that, they will overwrite. That's it. Then RAM files registers. We have direct addressing methods, function status register that is used for indirect addressing, status registers for various arithmetic and logical operation will result to one is a status register update, another one is a working register update right now. So that is given here. The multiplexer, what you are going to do, that is the, from which channel you are going to do, or from which memory that you are going to take, those are decided by the multiplexer. Then power up timer, oscillator startup timer, power on reset, watchdog timer, brownout reset, insert you decode, low voltage programming. All these things are there. Instruction decode and control, timing generation. This is for time generation. I told no clock circuitry will be there inside. So it accepts the crystal oscillator and generate the clock for the microcontroller. Then we have ports. Port A, port B, port C, port D, port E. Port E, as far as the port E is concerned, only 3 pins. Port A also not much pins. They are also limited pins only right now. Totally some 5 pins or 6 pins are used. Timer not timer 1, timer 2, 10-bit ADT, parallel slave port, and then data EEPROM, CCP 1, 2, synchronous serial port, use or compare voltage reference, everything we have here. Right? Flash memory, data EEPROM. So here, whatever that we discussed, no, I explained using pin diagram, right? That explanation given here. Oscillator or crystal or external clock input, oscillator or crystal or clock output, master clear or programming voltage, master clear programming voltage output, master clear, that means reset input. This pin is an active low reset to the device. So using this pin, we can reset the microcontroller, which is pin 1, by supplying an active low. Then port A is bidirectional IO port. They say digital IO analog input. Everything is explained here. Slave select input. So this where whatever the explanation that I gave, no, that they are that they have written it here.